Welcome back to Aurora Tech Channel. Today, I will be reviewing the Ender 5 S1. In 2020, I reviewed the Ender 5 Pro and made a few upgrades on it, including a Core XY conversion, and it still works pretty well. Creality just launched the Ender 5 S1, which has many upgrades, so I'm expecting quite a lot from this printer. The old Ender 5 Pro was selling at around $380 when it first launched, and the MSRP of the new Ender 5 S1 is around $550. So let's take a look at what kind of upgrades you can get. 1. A CR Touch auto bed leveling sensor. 2. A high-flow version of the Sprite Extruder Pro, which is a larger heated block and heat sink that allows it to melt filament faster to print at higher speeds. 3. A 50-15 blower for part cooling instead of a standard 40-10 blower on the Ender 3 S1. 4. A filament sensor is mounted at the side of the printer and uses a reverse Bowden tube to guide the filament to the extruder. 5. A 4.3-inch touchscreen with a new UI. 6. Other minor upgrades, including an extra rubber wheel on the X and Y axis, so you will see 4 wheels instead of the 3 that you normally see on most other printers. There is also a set of support arms for the print bed, a strain relief bracket for the print bed cable, and a better connector. 2 extra support brackets for the frame at the back, silicone spacers to replace the leveling springs at the corners of the bed, support for a full-size SD card and a USB-C connector, 2 handles on the frame, and other accessories like cable clips. So, these are the major and minor upgrades on the Ender 5 S1 I have seen so far compared to the Ender 5 Pro. As this printer claims to be able to print at a maximum speed of 250 mm per second, I will test out how well the stock setup works with Marlin firmware when printing at such a high speed, and try using the Sonicpad with Klipper firmware to control it. I would like to thank Creality for sending me this machine to review, and with that, let's get started. We have the base, a heated bed with a PC spring steel print surface, a set of Z-axis frames, 2 arms to support the other side of the heated bed, 2 brackets to reinforce the frame, 4 extrusions, the pre-assembled top frame with X and Y stepper motors, limit switches, and the print head, the filament holder, a spool of 200 grams of filament, the manual, and some tools. I will start by connecting the 4 aluminum extrusions to the base and securing them with 2 M5 screws at each corner. Then, put the top frame on and use another 2 M5 screws at each corner. I will use 2 filament boxes to hold up the print bed and tighten 4 screws to secure them. Then, flip it over and install the 2 arms to support the far side of the print bed, and use another 4 M5 screws to secure them. Next, put the Z-axis inside the box frame and secure it with 4 screws from the back, followed by 2 brackets to reinforce the frame. Mount the filament holder, and we can now connect some cables, starting with the X-axis stepper motor and limit switch, the print head ribbon cable, the Y-axis stepper motor and limit switch, the Z-axis stepper motor and limit switch, and the heated bed cable. There are a few cable clips that come with the printer, so use them to do some simple cable management. Then, install the Bowden tube to guide the filament from the runout sensor to the extruder. Finally, flip the switch of the power supply to your local voltage and turn on the machine. I will level the 4 corners of the bed, set the Z offset, and we can start auto bed leveling to create a mesh. The CR Touch will probe 16 points on the bed. Now, I will go to Cura and show you my setup. I have added a custom FFF printer, set the print volume, and selected the heated bed. The start and end G-code are just basic G-code like the kind on an Ender 3. I also set up a few print profiles to print at different speeds. The slowest one is 60 mm per second, which is set to be a bit faster than the standard 50 mm per second with 500 mm per second squared acceleration for an Ender 3. Also, take a look at the fastest speed, 250 millimeters per second, where the speed for travel and printing infill will be set to 250, the outer walls are 60, the inner walls are 125, and the first layer is also set to 60. Since the stock firmware limits acceleration to 2000, it won't change anything even if you set it to a higher number, unless you recompile the firmware or use Klipper. I also have another 250 millimeters per second profile that uses 5000 acceleration, so I will use this profile for some test prints with the Sonicpad that runs Klipper. I will begin by printing a 3D benchy and just print at 60 millimeters per second to make sure everything is working. I will also move the model to the front of the print bed to make filming easier. The estimated print time is 1 hour and 21 minutes, but since the printer profile I added was a custom FFF, the estimated time should not be accurate. The cooling of the 5015 blower fan is awesome, and as you can see, the bridging is printed very nicely. The print finally finished in 1 hour and 49 minutes. As the speed is only set to 60 millimeters per second, it's in line with most other 3D printers, and the layers and cooling of this print are really good. Next, I will print a calibration cube at the same 60 millimeters per second to ensure the belt tension of the step values are all correct. As expected, the cooling and layer lines are perfect, and just the top surface is a bit rough. When I measured the cube, I found the dimensions are very accurate and are even better than average. Then, I will try a larger print at a higher speed. I will print the Statue of Liberty model at 120 millimeters per second and 1500 acceleration. It says it's going to take almost 7 hours, but the actual print time should be around 8 hours. Compared to a standard speed printer like the CR10 Smart Pro, which would take longer than 15 hours, that print time is still pretty good. It took 7 hours and 40 minutes to finish, and the print looks pretty good. When printing at 120 millimeters per second, the surface is still very clean, and the only imperfect part is the crown, as these areas were basically printed in the air without support. Apart from that, I can't see other issues, and the back of the model looks nice as well. Up next, I will print this model of Superhero Mount Rushmore at 250 millimeters per second. The stock Marlin firmware set the maximum acceleration to 2000, and for now, I just set it back to 2000 for a more accurate print time estimate. It should take around 4 hours. For a standard speed printer like the Ender 3S1, it would take a little more than 16 hours. I will print one on each printer to compare the actual speed and quality. This is real-time speed, and it's quite impressive the first layer can be printed at this high speed. Now, the infill is printing at 250 millimeters per second, and it seems like the extruder and the hot end are both working very well, as I can't see any under extrusion issues. The print finally took 4 hours and 20 minutes to finish, and it doesn't look bad. After zooming in closely, the details on the print clearly aren't very clean, but we can wait for the Ender 3S1 to finish and compare the results. The Ender 3S1 ended up taking 15 hours and 55 minutes to finish, which is 3.6 times longer, but when I compared them side by side, the difference wasn't very big. If you zoom in really close, you can see the surface printed at 50 mm per second is cleaner than the one printed at 250 mm per second, but the quality of the one printed by the Ender 5S1 at 250 mm per second is still presentable. In order to print even faster with this printer, I will use the Sonicpad to control it, since the default Ender 5S1 profile in the Sonicpad is set to 5000 mm per second, and the input shaper has already been calibrated with the same model in the factory, so I will just keep the set of preset numbers. In the slicer, I will try to push everything to the max and set all acceleration to 5000, so even the first layer will be printed at 125 mm per second and see what happens. The estimated time is 2 hours and 5 minutes, so I expect the print to be finished in around 2 hours and 30 minutes, which is much faster compared to the Ender 3S1's print time, or over 10 hours. I will use the Moonraker plugin to send the print directly to the printer and start the print. If you want to know more about the Sonicpad, I made another video about it 2 weeks ago, and the link is under the video description. The print finished in 2 hours and 35 minutes, which is pretty amazing, except the support was too weak and fell before the chin was printed. Other than that, the print looks really good, and you probably wouldn't even believe it was printed in such a short time. When compared to the one printed by the Ender 3S1, which took almost 10 hours, the slower one does look nicer, with clearer surfaces and cleaner webs on the body and face. But once again, I am still pretty happy with the one just printed in 2 hours and 35 minutes, which is 4 times faster. Next, I will try using ABS to print this infinity cube, which requires high accuracy. At first, I tried to print at 250 mm per second with 2000 acceleration, but as you can see, the bottom didn't stick too well, and this part is not functional, and I cannot form a cube with it. So, I slowed it down to 80 mm per second and reprinted it. It is not as smooth as PLA, but I can still play with it. Then, I will try printing with PETG, but instead of regular PETG, I will try ARE1 Carbon Fiber PETG to print a pen holder. As PETG cannot be printed as quickly as PLA or ABS, I will slow it down to 120 mm per second with 2000 acceleration. It seems this carbon fiber PETG can still be extruded pretty well and can keep up with the 120 mm per second printing speed. The print finally took 5 hours and 15 minutes to finish. The detail on the tires look pretty nice, and this material is both rigid and quite easy to print. Following that, I will try some flexible TPU. So far, I've been able to print this ARE1 TPU with even a basic Bowden setup. This Sprite Direct Drive should be able to handle it pretty well then, so I just printed at 80 mm per second. As you can see, this TPU can be extruded smoothly at 80 mm per second. The print took 27 minutes to finish, and the top, the layers, and the bottom all look fine. Next, I will try printing with nylon carbon fiber. I will print a mount for the V6 hot end at 80 mm per second. Despite my PACF filament having never been dried since it was first opened, which caused some stringing, after some easy cleanup, the part is functional and fits well with the V6 hot end. I also switched back to the stock Marlin firmware to print some benchies and compare them side by side with the ones printed with the Sonicpad Klipper firmware. First, at 60 mm per second, I can't see any difference between these two benchies. Then, at 100 mm per second, there's also no difference as the surfaces of both benchies are clean. However, the differences start showing when printing at a faster speed at 120 mm per second. The surface printed with the stock firmware has some ringing and is not as clean as the one printed with Klipper. The difference will be even more obvious when printing at 250 mm per second with 2000 acceleration. Finally, I printed another Benchy at 250 mm per second with 5,000 acceleration using Klipper, but as the Benchy is small and there isn't much room for the print head to accelerate at such a high speed, it still looks similar to the one printed at 250 mm per second with 2,000 acceleration. When I'm using the Sonicpad, the stock touchscreen no longer has a purpose, so I just remixed the Sonicpad mount to mount it directly on this Ender 5 S1, as I can't find another Creality printer that deserves a Sonicpad more than this one. With the Sonicpad, this Ender 5 S1 looks even better. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. It can print a broad range of materials. I have printed PLA, ABS, TPU, PETG Carbon Fiber, polycarbonate, nylon glass fiber, and nylon carbon fiber with pretty good results. 2. The modified sprite extruder with a larger heater block and a larger heat sink works very well. I've been using the same retraction distance at 0.80 mm and 30 mm per second retraction speed for the original sprite extruder without any issues. The extruder and the hot end can also keep up with the high printing speed of up to 250 mm per second with 5,000 acceleration. 3. The cooling is probably one of the best out there. It uses a 50-15 blower with an optimized fan duct blowing strong air right at the part. The fan duct is 3D printed, but it's not that big of a deal as long as the part cooling is good, which is another critical factor for high-speed printing. 4. The box frame is sturdy. When the print bed only moves up and down, it's better than any bed slinger that swings the print bed back and forth as the y-axis. 5. The touchscreen UI has improved and is better than the Ender 3S1 Pro. I haven't seen any glitches or problems with the button placement so far, and the only thing I don't really like is the homing button. You can home the X and Y or home the Z, but you can't home all axes together with one click, which is strange, but overall the screen UI is better than other Creality UI. 6. Many small details have been improved compared to the Ender 5 Pro, like the cable management, as there's a silicone spacer to replace the leveling springs under the bed, a heated bed cable strain relief mount, a set of support arms for the bed, as well as the extra frame supports at the back, which are all nice. 7. This printer provides excellent print quality at 60 to 80 mm per second, has presentable print quality at 100 to 120, and has usable print quality at 250, except for parts that require high accuracy or fine details. Now for the cons. 1. It just has a single Z-axis, but has two arms to support the heated bed, so another set of Z-axis frames like the Ender 5 Plus would be better. 2. The rubber wheels and T-slot motion system may wear out faster when printing at high speeds, so linear rails would be even better. 3. As the maximum nozzle temperature is 300 degrees Celsius, this means many users will use it to print high-temperature abrasive filament like carbon fiber and glass fiber, but this printer only comes with two brass nozzles, which are MK8 nozzles but with longer threads. I expect this printer should come with a few hardened steel nozzles like the Ender 3S1 Pro. 4. The PC sticker sheet sticks too well to PLA when it's new, so when you see I've applied glue, it's just there to work as a release agent. 5. The Z-limit switch is at the bottom, so every time you home the printer, you have to wait for the bed to go all the way down and then come back up to the top. In my opinion, just using the CR Touch for Z-homing is more accurate and faster. I did mention this to Creality last week, and then we were doing some final editing for this video yesterday, and they have since released a new firmware that fixes this, so it will no longer be an issue. 6. This printer works very well with the Sonicpad, so it should come with Klipper firmware or a Sonicpad instead of Marlin firmware. As of right now, when I'm using it with the Sonicpad, the 4.3-inch touchscreen is completely useless. In conclusion, this printer prints very well out of the box and prints even better than the Ender 3S1, which is likely because the print bed only moves up and down and the box frame is sturdy. The hot end and the part cooling can also keep up with the high print speed, so it can really print at 250 mm per second with 2000 mm per second squared acceleration with the stock setup, and you can boost the acceleration to 5000 with Klipper firmware. Of course, if you are printing something that requires fine details and high accuracy, you should still stick with 120 millimeters per second or slower for the speed, but for most other models, I have no problems when printing at 250, even with a 5,000 acceleration. I would also like to suggest that Creality could make another full gear version for this printer that includes linear rails on the X and Y axis, for which I would be happy to pay an additional $40, another set of Z-axis frames like the Ender 5 Plus for another $60, a Raspberry Pi replacement board to run Klipper, a few pieces of acrylic boards, and a set of doors and an acrylic top to make this a fully enclosed printer for $100 to $150. So, if the full gear version of the Ender 5S1 was priced at around $700 to $800, it would probably be the ultimate hobbyist 3D printer. For now, the existing configuration is pre-selling at around $500, which is still pretty good. I would also like to see Creality offer a bundle for the Ender 5S1 and the Sonicpad, as they work together very well. If you are interested in this machine, I put the link under the description. That's it for this video. If you like this video, please hit the like and subscribe button and click the notification bell to receive new video updates. I will see you next time.